Hi, welcome to Business Statistics. Today's topic is hypothesis testing. In this video, we are going to work on one problem that relates to hypothesis testing of the population mean when the population standard deviation is known. Let's start with this problem. A researcher reports that the average salary of assistant professors is more than $42,000. A sample of 30 assistant professors has a mean salary of $43,260. At alpha 0.05, test the claim that assistant professors earn more than $42,000 per year. The standard deviation of the population is $5,230. To find whether to accept or reject the null hypothesis, and whether there is enough evidence to support the claim, we will follow the 7 steps. Feel free to pause this video if you want to try this problem yourself. So let's go ahead and begin with the first step. Step 1. State the null hypothesis and the alternative hypothesis and identify the claim. The null hypothesis is the average salary of assistant professors is equal to or less than $42,000. Always remember, the null hypothesis is the same or equal to, or there is no difference, or there is no change. On the other hand, the alternative hypothesis is the opposite of the null hypothesis. Now, the alternative hypothesis. This is what is being tested. The alternative hypothesis is the researcher reports that the average salary of assistant professors is more than $42,000. This is the claim. So, the researcher is conducting a test to prove that his claim is right. Step 1, done. Now let's move on to the second step. Decide the level of significance. In this problem, the level of significance, or the alpha, is 0.05. Okay, step 2, done. Now let's continue. Step 3, choose the appropriate test statistics. We need to determine what type of test we are going to do. You ask yourself, is this a one-tail test, or a right-tail test, or a left-tail test, or a two-tail test? The fact that the alternative hypothesis is more than $42,000, that means we need to conduct a right-tailed test. Step 3, done. Let's continue and do the fourth step. That is to draw the figure and establish the critical region. So let's draw a normal distribution, and we are going to shape the area to the right. Now, the level of significance is 0.05 or 5%. What is the critical value that corresponds to the area equivalent to alpha 0.05? We need to use the table for the standard normal distribution to find the value of z. For a right-tail test, we have to find and use the z value that corresponds to the area equivalent to 1 minus the alpha. Thus, 1 minus 0.05 equals 0.95. The areas closest to 0.95 are 0.9495 and 0.05. Take note, when the z-value is positive, we have to select the higher value. In this case, the z-value for 0.9505 is 1.65. This is the critical value. It separates the critical region from the non-critical region. The shaded area is the critical region. To determine whether to accept or reject the null hypothesis, we need to calculate the z-value and compare it to the critical value. That is the fifth step. We're going to compute the value of statistical test. Since the population standard deviation is known, the z-test formula will be used to find the test value. The formula is z equals x bar minus mu over population standard deviation divided by the square root of n. Now let us highlight the given data. So the sample mean is 43,260, while the hypothesized population mean is $42,000. The standard deviation for the population is 5,230, and the sample size is 30. So 43,260 minus 42,000 divided by 5,230 divided by the square root of 30 equals 1,260 divided by 954.38 gives us 1.32. If we place it on the graph, it's before the critical value. Notice that it is in the non-critical region. Now it's time to make a decision whether to accept or reject the null hypothesis. Step 6. So since the test value is lower than the critical value and it is in the non-critical region, the decision is to accept the null hypothesis. So what is our conclusion? So we're going to make a conclusion about the claim. So what is our claim? The claim is that the researcher claims that the average salary of assistant professors is more than $42,000. So do we have enough evidence to support that claim? What is your answer? Can we say that there is enough evidence to support the claim? Since we accept the null hypothesis, then our conclusion is there is not enough evidence to support the claim that assistant professors earn more than $42,000 per year. Done. Thank you for listening.